morning. So sorry that I am out today. Unfortunately, in the middle of the night, daughter Elizabeth woke up with the bad case of the flu. So it's been a fun time at the Budick household since about 12:30 a.m. Sweet action, in the opposite sense of sweet action. Anyway, welcome to Tuesday for AP College Credit Stats. Okay, happy second hour to you. Happy Tuesday. I'm not sure who my substitute is at this point, but whoever it is, make sure that you welcome them in to the room. After all, it is K208, where the K stands for yes, kindness. Very good, very good. Make sure you make the sub feel welcome and take care of him or her the best way possible. And that way is getting all your work done. So first things first, all the copies that you need for today are located up on the table. When you're facing the table, your copies will be the second row. Okay, everything related to Unit 8. So the 8.1 to 8.2 quiz, and then the Hershey's activity, which way will the Hershey Kiss land, and then the homework that goes with lesson 8.3 as well. Okay. The nice part about today is all of the answer keys for the quiz and for the homework have been posted in Google Classroom. So it's basically just getting those done, completion, going through those. We'll talk about the questions and stuff hopefully when I return tomorrow to make more sense of this material. Okay, but the big thing today is getting done with the quiz, the lesson itself, go through the slides that that have been shared, and I'll kind of go through those on the video as well, and then also going through the homework, and you can use the answer keys that are in Google Classroom. Okay. All right, so once you have finished up the quiz on paper today, so everyone is just doing it all on paper. There is no Google Doc to fill out as a team. You are just answering the quiz on your own sheet of paper. I will go through and make sure that you have that completed tomorrow. So check for completion grade. Once you finish the quiz, you'll go through the slides. And you'll notice the first slide here, Hershey Kisses. So I will have Hershey Kisses for you to eat tomorrow. And rather than having the sub worry about you as a team tossing them up in the air to see what proportion land flat, which ones land on the side, I'm just going to give you the data today, and they're going to kind of walk through some of the key components of how to create a confidence interval. Okay, so that's what we're doing today, constructing confidence intervals for proportion. So if I were there today, each team would get a solo cup of 50 Hershey Kisses that you would toss up in the air, and you would see the proportion that would land flat out of 50. Okay, so pretend made-up data here. Boots tossed them up, and he got 21 of the 50 to land flat, or 42%, or 0.42. Our population is all Hershey Kisses. The parameter is what we're trying to figure out, the true proportion of all tosses that will land flat. Our sample is the 50 Hershey Kisses that are in the solo cup, and my statistic, my p hat, okay, 0.42. So now we use that information. Going through a confidence interval, so checking conditions. Okay. Do we have a random sample? Yes, so that we can generalize to the population. In this case, all Hershey Kisses tosses. That's condition number 1. The formula for standard deviation, you've seen this before, the square root of p, 1 minus p over n. Okay, was this condition met? Yes. Why? Because our sample size is less than 10% of all possible tosses of Hershey Kisses. However, because we don't know the true proportion, okay, we use what's called standard error in your gold packet. When you look at proportions, sampling distributions, you'll see all the way to the far right, all the way to the far right. It's going to be the square root of p hat, 1 minus p hat over n. So using my statistic, because I had 42% that landed flat, it would be the square root of 0.42 times 0.58 over 50. And there is our standard error. Hey, let me go full screen here just so we can see things a little bit better here. Okay. Now, would it be appropriate to use a normal distribution model? Yes. Okay, you're checking large counts. Both large counts are greater than or equal to 10. This is condition number 3. And don't worry, I will have a packet to help you remember all the conditions. Okay, so it's easy for you to kind of just go through a checklist. Okay, moving on. General formula for a confidence interval, and I pointed this out to you yesterday when you shot the papers in the basket. You take your point estimate and you add and subtract your margin of error. To calculate the margin of error, we need to know how many standard deviations we can expect the sample proportion to vary from the true proportion. In a normal distribution, 95% of the data lies within 2 standard deviations of the mean. Okay, we learned that with the empirical rule. However, this is not totally quite accurate. It's not perfect 2 standard deviations. Okay, when you're looking at a normal curve and how far 95% of the data is. Okay, now it says use table A or inverse norm. We're going to use Desmos. Okay, so go into Desmos. You can practice doing this. Okay, so for example, normal dist, because we're just looking at any normal distribution, a standardized one, where the mean is 0, standard deviation is 1. Okay, when we want to do, for example, 95% of the curve. Okay, and let me just get a normal distribution here so you can see exactly what I'm talking about. Show you a picture here. Okay, if I want to have 95% of the curve, okay, that means that what is left on the tails is going to be like 2.5%. Okay, 2.5%. That's why the point here is 0.975. So from negative 1.96 to a positive 1.96. Okay, and you can see that I have 95% of the curve. These are the critical values. This lets me know that I have 95% of the curve. Now, how do you get that 1.96? Well, normal dist, the inverse CDF, to figure out what the value is. In other words, the z-score of how far I need to go left and right to capture 95% of the curve. Okay, so that's what all of these values on this page are all about. Okay, so 80%, I need to go 1.282 standard deviations above and below. 90%, 1.645. 95, 1.96, like we just saw. 99%, 2.576 standard deviations. Okay, we can use Desmos to help us calculate these values. And don't worry, if this isn't making sense today, Boots will be back and I will gladly show you all of these again on Desmos, and we'll go through it step by step. Little new kids on the block. Okay, so now using all that information, we're going to calculate the confidence interval for our Hershey Kisses. Okay, so we want a 95%, so there's our critical value, 1.96, and this is our standard error from the previous page. So there is our total margin of error. Okay, margin of error is the critical value times the standard error, which is what you see on number 9 here. Okay, so now when I take my point estimate, add and subtract my margin of error, there is my lower and upper bound. Okay, now if we would have done this with a class, okay, we would have been able to see more examples of confidence intervals, and we would have been able to see point estimates here, there, everywhere, and then vertical line where what proportion captures all of those? Okay, but obviously we don't have that today because you're not doing it as a team. Okay, I'm just kind of going through this with you. Okay, this is right here the entire formula for a confidence interval for proportion. Okay, so you take your point estimate, your p hat, your z star, that is the critical value. In this case, it was 1.96. And then inside the square root is our standard error, how much we're going to add, subtract as part of the critical value to get our entire confidence interval. Okay. So as far as notes go, conditions, and like I said, I will have a sheet for you, so it's a nice little cheat sheet, so you never forget what the conditions are for checking if you can, in fact, create a confidence interval. Okay. Why these conditions are so important. Okay. And then some of the important critical values. Okay. Now, I showed you on Desmos. I wanted to also talk about inverse norm because they talk about inverse norm on the sheet. This would also be how you would use the TI Inspire, okay, for our AP Stat exam students if you're going to use the TI Inspire as well. Okay. There's the full formula. Okay. And then go ahead and go through the check your understanding. It's a nice way to kind of go through the process again. But here, let me just show you another thing on Desmos that's pretty cool. So in Desmos, we also have inference. Okay, if you go into z-test for proportion, okay, so I had 21 successes out of 50. Okay, and you click on create test here. Let me get this out of the way. All right, and then click on confidence interval, and you get this down. Let me scroll here. Okay, you can see that I have the lower and upper bound for my confidence interval, which is exactly what we had for our confidence interval, 0.283, 0.557, 0.283, 0.557 when you round 3 decimal places. So you can also do confidence intervals right in Desmos. Oh, sweet action all the way. Okay? So make sure you've gone through all of the slides to check your understanding. Make sure you have obviously finished up the quiz on paper today, no Google Doc. And then also make sure that you have also finished up, one second, the homework page for today. Okay, this is 8.3. All of your sheets, like I said, are the second row on the little table. If you need anything, shoot me an email or shoot me a message, and I will be happy to answer your questions. Okay, remember to be kind to the substitute teacher, whoever that may be, and hopefully I will see you all tomorrow, Wednesday. Have a great rest of your Tuesday. Thank you so much. Bye-bye.